For section 6.2, day 2, I'm going to first of all just give you guys a couple of warnings. You may want to pause the video to get a couple of things written down. The very first one is what I challenged you guys to do with your unit circle. I asked you guys to write down all of the identities. From section 6.1, that would have been the fundamental 8 identities that I still stand by. You should memorize them. And then, okay, the identities that we learned last day, we had a first date with the sum, difference, and double angle identities. What I really think you should do is pause the video and have them neatly, all identities written down here, so this becomes your key resource for studying the rest of chapter 6. It's worth your time doing that. Now, the second time where you may want to be stopping the video is after each time when I finish a whiteboard and then erase, because the PDF notes do not have this section in it. I apologize for that. There's a couple of sections where they are missing, and so we'll deal with writing it down on the fly. Now, for today, we start to really see the power of the identities and the unit circle together. What we're going to do all day today is find exact values, and let's start off with an oldie but a goodie, and this is just to set the stage. Okay, so let's say you were supposed to find the sine of 45 degrees exact value. When it says exact value, that means no calculators allowed, and Canadian universities, we don't use calculators, so you need to have some skills. So sine of 45, you've known this for over a full course. Sine is y over r is always 1. You go to 45 degrees on the unit circle, and root 2 over 2 is the exact value. It's the same decimal, 0.707, and repeating that the sine of 45 is. Most people, most mathematicians would say this is a better value, because when you have a decimal, it's either rounded or truncated. This is perfect. No rounding or truncating. Now, that is just to set the stage. That's not what we're doing today. This very first question is what we're doing today, and then you start to see the power of the identities. Let's say you were supposed to find the exact value of the sine of 15 degrees. That means no calculators, no technology allowed. How would you do it? Well, teasing you would be, hey, pull out your unit circle. Where's 15? Well, it's not on here. So then you'd be left wondering, well, how can we do this? Now, here's how we begin today. What we are going to do is we're going to take 15 degrees and we're going to break it up. Now, don't write this down because this is a waste of your time. 10 plus 5. I cannot be arrested for doing this because 10 plus 5 is 15, but it does us no good. I could even do something silly, like I could subtract 17 minus 2. Yes, that's 15 degrees. It doesn't do us any good. Now, you're going to immediately see how this is going to do us some good. Let's say I wrote down 45 degrees minus 30 degrees. That is definitely 15, and you definitely immediately realize that's better, because 45 and 30, they are good angles. Why are they good? Because they're on your unit circle. Now here's where again the power of the identities come in. What we simply need to do is to find on the identities, which is the identity that comes from two angles subtracted. The textbook would call the first one A and the second one B. And so again, section 6.2 day 1, that first date with the identities just to get to know them pays off. We now know that this identity exists, and we know it looks like this. It goes sine of A cosine of B minus cosine of A and then sine of B. And this has been proven true for all angles that you could put in, that this will be the same as the original amount. Here's how this calculation unfolds. All we simply need to do is to drop in what are each of the values. Well, A is 45, B is 30, again A is 45, B is 30, and we can make these calculations. What I'm going to do is just set up a little template with open brackets, and we're going to drop in each value. Now we can go back to our unit circle. Sine of 45, well, that's y over r. We already know that's root 2 over 2, so I can drop that in. Cosine of 30, well, that is going to be a square root 3 over 2. When we do the unit circle, x over r. Cosine of 45, with a little bit of work on the unit circle, is root 2 over 2. And sine of 30 is a half. Here's our grand finale. If I was going to multiply these two fractions, square root 2 times square root 3 is root of 6. And then 2 times 2 is a 4. Root 2 times 1 is just a root 2, and then the denominator is a 4. Well, I can write it as a common denominator of 4. We are done. This is the exact value. If you were to type this into your calculator, square root 6 minus square root 2, it equals, divide by 4, It is the exact same as the sine of 15. And so this is now showing the power of the identities. Now, for your next example, nothing dramatically new, we'll do a cosine one, and there's definitely options, you get your choice, and I'll tell you what I usually choose. So let's say we had to find the exact value of the cosine of 105. You glance quickly at your unit circle, that doesn't exist on the unit circle, but it's not that bad to figure out what this would be without a calculator. What you would do is you would break it up into two angles, added or subtracted to be 105. Yes, you could write down 100 plus 5, but that does you no good because 100 and 5 are not on your unit circle. We want to choose something like 60 and 45. Now, just before I finish this second last example, I will tell you guys that there are other angles that would be good, that would work. And just imagine without writing down 150 subtract 45. That still is 105, and 150 and 45 are both on the unit circle. It would give you ultimately the same answer. Just along the way, there might be a couple of subtle differences, but it would come out the same in the end. So don't panic. You can take your choice. What I usually do is I try to stick to the first quadrant angles as much as I can, because then they're always positive, and then I don't miss something little. So here's how this guy would go. We have to find an identity where it goes two different angles. Again, the textbook calls them A and B, that are added together. Well, this comes from the cosine of 60 plus 45. Well, this is coming from the cosine of angle A times the cosine of angle B, and then there's a minus. Don't ever make any kind of associations, make up any little memorized rules at this moment. Sine of A, sine of B. And we drop in our values. The value of A is 60. The value of B is 45. Then again, you drop them in. We have a 60, and then we have a 45. And here is what essentially happens. We just need to figure out each of these four values, multiply, subtract, and we will have our exact value. No calculator needed. So the cosine of 60 is a half. The cosine of 45 was root 2 over 2. Sine of 60 is square root 3 over 2. And sine of 45 is square root of 2 over 2. And now here's what happens. We have, I'll do the denominator first, 2 times 2, 4, 2 times 2, 4. We have a common denominator of 4. And in the numerator, 1 times root 2 is root 2. Root 3 times root 2 is root 6. And we're done. We have our exact value of the cosine of 105. Now, what I'm going to do is erase, and we're going to move to our final example, which is tangent. And tangent starts off just as lovely, and you might be thinking, I love this stuff. But tangent has just one little mini dark side, and that is in how you finish. So let's say we had to do the tangent of 15 degrees. We have to figure out what this is equal to. Now, no monkey business. Let's get right down to it. Tangent of 15. What we are going to do is we're going to take it and we're going to break it up into two things, added or subtracted, that are good. You could go 45 minus 30. We could go 60 minus 45. That's the one that I'm going to do. They will both ultimately in the end give you the same answer. Then we look up, well, what is this coming from? Okay, this is coming from tangent of two things subtracted. That would be coming from tangent of angle A minus tangent of angle B. You can write that down before, or you can go right to the angles if you're comfortable. And then it goes 1 plus tangent of 60 multiplied by tangent of 45. Okay, so if you're going to write down the identity, great. If not, make sure you double check yourself that you got the signs right, everything's in the right order. And then here's what happens. Okay, I'm going to set up a little template again. We need to figure out what is the tangent of 60, the tangent of 45, and then again over here, those two multiplied together. And it's really quite nice at the start. The tangent of 60 is the only time you really have to work a bit. I'll just do that off to the side in a do not write down zone. Tangent is y over x at 60 degrees. The y value is root 3 over 2. The x value is a half. If you imagine the old flip it up, the 2's cancel out and we just have a root 3. So the tangent of 60 is a very nice root 3 that I drop into both places. Tangent of 45 is even nicer. When you look it up, the y over the x, it's the same thing divided by itself. It's a 1. Now here's where we are. If I would just eliminate the brackets, tidy it up, I have a square root 3 minus a 1, And then I have a 1 plus just a square root 3. Now you might be thinking, hey, just as sweet as before, are we done? Unfortunately, the answer is no. University professors would expect you to finish it all the way. They would expect you guys to rationalize by multiplying top and bottom by the conjugate radical, which is 1 minus root 3. Again, all of that work in pre-calc 20 hopefully is paying off. Now, what would this equal? It's going to be a little bit of a mess. Okay, and I'll squeeze it here, and then we'll have to finish the final answer by erasing. When you were doing the conjugate, okay, the conjugate radical, the denominator is the best part. First times first is 1. The outer and inner cancel out because they're the opposite sign, and last times last is just a minus 3. The numerator, you got no choices. You got to FOIL this out in full. First times first is a root 3. The outer is a minus 3. The inner is a minus 1. And last times last is a positive root 3. Now you're still not done yet. You have to do a little bit of simplifying. What I'll do is I'll just erase the stuff up here so we can keep that as our working model. We're almost there. So what would this be in its grand total? The denominator has a minus 2. The numerator, if we just simplify it again, I'm going to do the numerical values without radicals first. Negative 3, negative 1 is a negative 4. 1 root 3 plus another 1 root 3 is 2 root 3s. Here's how we do our grand finale. Each of these numerators is divided by the common denominator. Do each one separately. Negative 4 divided by negative 2 is a positive 2. Then, if you just pretend that negative 4 disappears for a moment, 2 divided by negative 2 is negative 1, root 3. Now we have our final answer. This is the exact value of the tangent of 15 degrees. The simplifying is a little bit harder than when you're doing sine and cosine. Now here's another problem with today. The PDF notes do not have the assignment for the day. It is page 306, and you do number 8, all letters. Sorry again that that's not in the PDF notes.